Today in this lecture, we will discuss about the overcurrent line protection by inverse time relays. In previous lecture, I have discussed about the overcurrent protection by using a definite time relays. So there was a drawback in the previous system that we have a definite time relays, so at a fixed time only these relays will operate. Now that drawback has been overcome by using the inverse time relays. What is inverse time relays? That is, if current is more, then time will be less for operating the circuit breaker. So on this principle, the inverse time relays operates. Let us see a figure of radial filter has been shown here. At point A, CB is placed. At point B, CB1 is placed. At point C, CB2 is placed. And at point D, CB3 is placed. Let us consider that at point F there is a fault. So once there is a fault at point F, it means the nearest circuit breaker which is placed to the fault point, that is CB3, should operate first. And if CB3 doesn't operate, then CB2 should operate, because CB2 time setting has given a more than the CB3 time, and successfully we have increased the timing for other relays once we are moving from load to source. So if CB1 is also not operating, then the CB placed at A will operate, and because at this point the current flowing through this CB will be maximum, so since this is an inverse time relay, so operation time will be reduced and this relay will operate first. Same thing is written here, that is, the drawback, as we discussed just in definite time overcurrent protection of transmission line, that can easily be overcome by using inverse time relays. In inverse relays, the time of operation is inversely proportional to the fault current that has been described here. Same thing has been described here, which I have discussed now, that in the above figure, overall time setting of relay at point D is minimum, and successfully this time setting is increased for the relays associated with the points toward the point A. So as soon as we move toward the point A, the time setting is successfully increased. Now in case of any fault at point F, will obviously trip the CB3 at point D. In failure of opening a CB3, the CB2 will operate, as overall time setting is higher in that relay at point C. Although the time setting of relay nearest to the source is maximum, but still it will trip in shorter time if major fault occurs near the source, as the time of operation of relay is inversely proportional to the fault current. So what is telling that once we provide the inverse time relays and CB will operate nearest to the fault point, but if that CB doesn't operate, then next CB will operate, and as soon as we are moving toward the source side, the CB which is placed near to source will have a maximum fault current. So that is inverse time relay. It means for the maximum current, the time of operation will be minimum, so it will operate immediately to avoid further damage to the system. So this is the overall operation of the inverse time relays. Now we'll discuss another topic, that is called the overcurrent production of parallel feeders. So as we know that, what is the advantage of placing the parallel feeders? That is, if one feeder is unable to supply the complete load, then two parallel feeders are placed so that the load can be shared between the two feeders and that can be easily dispatched towards the load. Second thing, advantage of having a parallel feeder, that if a fault happens at one feeder, then second feeder will carry on supplying the power to the rest of the system. That's why we are using parallel feeding system. But this system is little bit different from the radial feeder system, because in radial feeder system we have placed only non-directional relays. We have not placed any directional relays. But here this is a complex system. So in this parallel feeder system, we have placed the directional relays and non-directional relays, or directional relays or reverse power relays. So we will see the diagram and we will explain further. So same thing has been written here, that for maintaining the stability of the system, it is required to feed a load from source by two or more than two feeders in parallel. If fault occurs in any of the feeders, only that faulty feeder should be isolated from the system in order to maintain the continuity of supply from source to load. These requirements make the production of parallel feeder little bit more complex than the simple non-directional overcurrent production of lines, as in the case of radial feeders. The production of parallel feeders requires to use of directional relays and to grade the time setting of relays for selective tripping. Accordingly, we time grade the relays as per our requirement. Now let us see, in this figure two parallel feeders have been shown here. This is the sending substation and this is the receiving substation. And this is feeder 2 and this is the feeder 1. So there are two parallel feeders. Now if we talk about the circuit breakers, that is, at point B circuit breaker is placed near the sending station, and at the point Q circuit breaker is placed, that is, near the receiving station. But this is the non-directional relay which is placed at the point B, and CB which has been placed at the point Q, it is called the directional relay. Similarly, relays which are placed at point A, this is the non-directional relay, and CB which has been placed at the point P, that is called the directional relay. So how this system is operating, let us discuss. Now let us assume that a fault is created at point F in the feeder 1 between the CB placed at point A and P. So the fault current will be flowing through this faulty point from both sides. That is, through feeder 1 the current is IA is flowing, and through feeder 2 current IB is flowing to this faulty point. Now what will happen, that since CB at placed point B is non-directionally, so nothing will happen in this case. This is called the direction relay, but in direction relay current is not flowing as per the direction indicated for this relay, so this relay will also not trip. Now this IB will flow from here to this CB, which is placed at the point P. And since this is also a direction relay, so this IB current is flowing now as per the direction of this CB has been shown. It means this relay will operate as this is called the directional relay or reverse power relay. So this relay will trip and the feeder 2 will be disconnected from the faulty point F. That is how in parallel system this directional relay gets operated. Now feeder 1 is still continuing supplying the fault current to the point F. So now the current flowing through feeder 1, that is IA, will increase further, and since this is the instantaneous relay, that is the non-directional relay, so as soon as the current exceeds beyond the set value of this relay, which is placed at the point A, so this CB will be also tripped off. So as soon as this CB is tripped off, both the feeders, that is feeder 1 and feeder 2, both the feeders are now disconnected from the faulty point. It means now fault point is not getting any supply from anywhere. So this is how the parallel feeder production system operates. Same thing has been explained here, that there are two feeders connected in parallel from source to load. Both of the feeders have non-directional overcurrent relay at the source end. These relays should be inverse time relays. Also, both of the feeders have directional relay or reverse power relay at their load end. The reverse power relay used here should be instantaneous type. That means these relays should be operated as soon as the flow of power in feeder is reverse. The normal direction, so the normal direction of power as shown indicated in this figure or in this figure, as per the direction shown, if current flows, then the circuit breaker will operate. So mostly these directional relays are instantaneous relays. These are called the instantaneous relays. It means as soon as power gets reversed or current flow direction gets reversed, then instantaneous response will be obtained from the circuit breakers. And the circuit breakers which are placed near the sending end, sending substation, so they are the inverse type relays. So once feeder 2 is disconnected from the faulty point and only feeder 1 is supplying the fault current, so this fault current IA will increase to a maximum value, so its operating time will reduce sharply and this relay will operate immediately, because this relays these both A and B relays are the inverse type relays. That is how this system operates. So same thing has been explained here, which I have already explained to you. That is, now suppose fault occurs at point A, say the fault current IF. This fault will get two parallel paths from source that is one through circuit breaker A only and other via CBB, feeder to CBQ, load bus and CBP. This is clearly shown in figure below, or figure below means in previous slides I already have shown you this figure where IA and IB are the currents of the fault shared by feeder 1 and feeder 2 respectively. Now IA is flowing through CBA, IB is flowing through CBP. So as the direction of flow of CBP is reversed, it will trip instantly. It will trip instantly, but CBQ will not trip as the flow of current or power in this circuit breaker is not reversed. As soon as CBP is tripped, the fault current IB stops flowing through feeder and hence there is no question of further operating the inverse time overcurrent relay. IA still continues to flow even CBP is tripped. Then because of the overcurrent IA, CBA will trip. In this way, the faulty feeder is isolated from the system. So this is what the protection of parallel feeder, how the both the feeders can be protected supplying the power to the faulty point. So today in this class we have discussed two topics, that is drawbacks associated with the radial feeders where we don't have an inverse time delays that can be avoided if we use the inverse time delays for production of feeders, that already I have discussed today. And second thing, what is the advantage of taking the parallel feeder and how they are protected. This has been explained today in this class. Further we will discuss in the next class.